Page 9. SMED, Shigeo Shingo 1983. Chapter 3. Fundamentals of SMED. 3.1. The birth of SMED. In the spring of 1950, I conducted an efficiency improvement survey at Toyo Kogyo's Mazda plant in Hiroshima, which at the time manufactured three-wheeled vehicles. Toyo wanted to eliminate bottlenecks caused by large body molding presses of 350, 750, and 800 tons that were not working up to capacity. I immediately conducted an on-site inspection, and then made the following request of the section manager in charge of manufacturing. Will you let me do a week-long production analysis with a stopwatch so I can get an idea of the work these big presses do? He replied that it would be a waste of time. He already knew that the presses were the cause of the bottlenecks and had assigned his most skilled and conscientious employees to work on them. He had the three presses working around the clock and felt that the only way to improve productivity further was to buy more machines, which is exactly what he hoped top management would do. That sounds pretty bad, I said. But listen, let me do an analysis anyway. If it turns out that there's no other way to eliminate the bottlenecks, then I'll advise management to buy the machines. With that argument, I was finally permitted to conduct a fact-finding survey. On the third day, there was a die change on the 800-ton press. Workers removed the old die and then started rushing about all over the place. I asked the operator what was going on. He replied, "One of the mounting bolts for the new die is missing." I was sure they were all with the die, but I can't find the last one and I've been looking all over for it. "When you find it," I said, "you'll come back to the die, won't you?" "I'll wait for you here." "All right," he replied. "Having you around here gives me the jitters, anyway." I sat down by the machine and waited. After more than an hour, the operator rushed back, drenched with sweat and brandishing a bolt in his right hand. "Ah," I said, "you've found it." "No," he answered. "I didn't actually find it. I borrowed a long die bolt from the next machine over there. I cut it to make it shorter, then threaded it. That's what took so long. It wasn't easy, I can tell you." I said a few words of sympathetic encouragement, but a sudden thought started me worrying. "You cut it to the right length for this machine, but what are you going to do when you have to set up the machine you took it from? Does this kind of thing go on all the time?" "No," he replied, "I wouldn't say it happens all the time. It's just something that gives us trouble now and then." As Figure 3.1 shows, the large press was actually engaged in the main manufacturing operation for less than 3% of that entire day. It dawned on me at that point that setup operations were actually of two fundamentally different types. Internal setup, ID, such as mounting or removing dies, that can be performed only when a machine is stopped. External setup, OD, such as transporting old dies to storage or conveying new dies to the machine, that can be conducted while the machine is in operation. Preparing the bolts was an external operation. It was senseless to stop the operation of an 800-ton press because a bolt was missing. All we had to do was establish an external setup procedure, verifying that the necessary bolts were ready for the next setup. We established a process for thoroughly sorting all the bolts and putting the necessary ones in boxes. We also improved the entire procedure by performing all possible aspects of the setup externally. This raised efficiency by about 50%, and the bottleneck was dissipated. Ever since this episode, I have made it a policy to distinguish clearly between internal and external setup. Thus the newly born SMED concept took its first steps at Toyo Kogyo. 3.2 The second encounter. In the summer of 1957, I was asked to do a study at the Mitsubishi Heavy Industries shipyard in Hiroshima. When I asked the plant manager, Matsuzo Okazaki, what the problem was, he told me that a large, open-sided planer used to machine diesel engine beds was not working up to capacity and that he wanted to streamline the operation. After doing a production analysis, I realized that the marking off procedure for centering and dimensioning the engine bed was being conducted on the planer table itself. This reduced the operating rate tremendously. As I discussed this with Mr. Okazaki, an idea came to me quite suddenly: why not install a second planer table and perform the setup operation on it separately? That way, we could switch tables as we shifted from one lot to the next, and there would be a significant reduction in the amount of time the planing operation was interrupted for each setup. Mr. Okazaki agreed to this change on the spot. On my next visit to the factory, I found that the extra planer table had been completed. This solution resulted in a 40% increase in productivity. Mr. Okazaki and I were ecstatic and toasted one another on our accomplishment, yet even now I regret one thing. If I had grasped at the time the overwhelming importance of converting an internal setup to an external one, the SMED concept would have been perfected some dozen years sooner. 3.3 The third encounter. In 1969, I visited the body shop at Toyota Motor Company's main plant. Mr. Sugera, the divisional manager, told me they had 1,00-ton press that required 4 hours for each setup change. Volkswagen in Germany had been performing setups on a similar press in 2 hours, and management had given Mr. Sugera clear instructions to better that time. Together with the foreman and plant manager, I set about seeing what could be done. We took special pains to distinguish clearly between internal and external setup, id and od, trying to improve each separately. After 6 months we succeeded in cutting setup time to 90 minutes. We were all pleased with this success, but when I revisited the body shop the following month, Mr. Sugera had some rather startling news for me. Management had given him orders to further reduce setup time, to less than 3 minutes. For an instant I was dumbfounded at this request. But then an inspiration struck: why not convert id to od? A number of thoughts followed in rapid succession. On a conference room blackboard I listed 8 techniques for shortening setup times. Using this new concept, we were able to achieve the 3-minute goal after 3 months of diligent effort. In the hope that any setup could be performed in under 10 minutes, I named this concept single-minute exchange of die, or SMED. SMED was later adopted by all Toyota plants and continued to evolve as one of the principal elements of the Toyota production system. Its use has now spread to companies throughout Japan and the world. Mr. Taiki Ono, formerly a vice president at Toyota Motor Company and now a consultant, wrote about SMED in an article entitled Bringing Wisdom to the Factory, which appeared in the journal Management, published by the Japan Management Association, in June 1976. Until some 10 years ago, production in our firm took place as much as possible during regular working hours. Changes of cutters, drills and the like were relegated to the noon break or the evening. We had a policy of replacing the cutters after every 50 items. Yet as production has risen over the past decade or so, machine operators have often begrudged the time needed for these changes. For the multi-grinder in particular, replacing the numerous cutters and drills took half a day. Since afternoon production would stop whenever a replacement was made on a weekday, workers were forced to work temporary shifts on the following Sunday. This was uneconomical and therefore unacceptable. Since we also wanted maintenance to be done during working hours, we began to study the question of how setup changes could be performed in a very short period of time. Shingo, of the Japan Management Association, was advocating single-minute setup changes, and we felt that this concept could be of great service to us. It used to be that after spending half a day on setup, the machine might be used for only 10 minutes. Now, one might think that since the setup took half a day, production ought to continue for at least that long. This, however, would have left us with a lot of finished products we could never sell. We are now looking into cutting setup times down to a matter of seconds. Of course, this is easier said than done. Somehow, though, we must reduce the amount of time needed for setup changes. This passage underscores the impact of setup time reductions on the improvement of production activities as a whole. The development of the SMED concept took 19 years in all. It came about as the culmination of my ever-deepening insight into the practical and theoretical aspects of setup improvement. The finishing touches were stimulated by Toyota Motor Company's requirement that we reduce setup time on a 1,000-ton press from 4 hours to 90 minutes. I would like to stress that SMED is based on theory and years of practical experimentation. It is a scientific approach to setup time reduction that can be applied in any factory to any machine. 3.4 Basic steps in the setup procedure. Setup procedures are usually thought of as infinitely varied, depending on the type of operation and the type of equipment being used. Yet when these procedures are analyzed from a different viewpoint, it can be seen that all setup operations comprise a sequence of steps. In traditional setup changes, the distribution of time is often that shown in Table 3.1. Let us examine each of these in greater detail. Preparation, after-process adjustment, checking of materials, tools, etc. This step ensures that all parts and tools are where they should be and that they are functioning properly. Also included in this step is the period after processing, when these items are removed and returned to storage, machinery is cleaned, etc. Mounting and removing blades, tools, parts, etc. This includes the removal of parts and tools after completion of processing and the attachment of the parts and tools for the next lot. Measurements, settings, and calibrations. This step refers to all of the measurements and calibrations that must be made in order to perform a production operation, such as centering, dimensioning, measuring temperature or pressure, etc. Trial runs and adjustments. In these steps, adjustments are made after a test piece is machined. The greater the accuracy of the measurements and calibrations in the preceding step, the easier these adjustments will be. The frequency and length of test runs and adjustment procedures depend on the skill of the setup engineer. The greatest difficulties in a setup operation lie in adjusting the equipment correctly. The large proportion of time associated with trial runs derives from these adjustment problems. If we want to make trial runs and adjustments easier, we need to understand that the most effective approach is to increase the precision of the preceding measurements and calibrations. 3.5 Setup improvement, conceptual stages. The conceptual stages involved in setup improvements are shown in Figure 3.3. 3.6 Preliminary stage, internal and external setup conditions are not distinguished. In traditional setup operations, internal and external setup are confused. What could be done externally is done as internal setup, and machines therefore remain idle for extended periods. In planning how to implement SMED, one must study actual shop floor conditions in great detail. A continuous production analysis performed with a stopwatch is probably the best approach. Such an analysis, however, takes a great deal of time and requires great skill. Another possibility is to use a work sampling study. The problem with this option is that work samples are precise only where there is a great deal of repetition. Such a study may not be suitable where few actions are repeated. A third useful approach is to study actual conditions on the shop floor by interviewing workers. An even better method is to videotape the entire setup operation. This is extremely effective if the tape is shown to the workers immediately after the setup has been completed. Giving workers the opportunity to air their views often leads to surprisingly astute and useful insights. In many instances these insights can be applied on the spot. At any rate, even though some consultants advocate in-depth continuous production analyses for the purpose of improving setup, the truth is that informal observation and discussion with the workers often suffice. 3.7 Stage 1. Separating internal and external setup. The most important step in implementing SMED is distinguishing between internal and external setup. Everyone will agree that preparation of parts, maintenance and so forth should not be done while the machines are stopped. Nonetheless, it is absolutely astounding to observe how often this is the case. If instead we make a scientific effort to treat as much of the setup operation as possible as external setup, then die time needed for internal setup performed while the machine is off can usually be cut some 30% to 50%. Mastering die distinction between internal and external setup is thus the passport to achieving SMED. 3.8 Stage 2. Converting internal to external setup. I have just explained that normal setup times can be reduced 30% to 50% by separating internal and external setup procedures. But even this tremendous reduction is insufficient to achieve the SMED objective. The second stage, converting internal setup to external setup, involves two important notions. 1. Re-examining operations to see whether any steps are wrongly assumed to be internal. 2. Finding ways to convert these steps to external setup. Examples might include preheating elements that have previously been heated only after setup has begun, and converting centering to an external procedure by doing it before production starts. Operations that are now performed as internal setup can often be converted to external setup by re-examining their true function. It is extremely important to adopt new perspectives that are not bound by old habits. 3.9 Stage 3. Streamlining all aspects of the setup operation. Although the single-minute range can occasionally be reached by converting to external setup, this is not true in the majority of cases. This is why we must make a concerted effort to streamline each elemental internal and external setup operation. Thus Stage 3 calls for a detailed analysis of each elemental operation. The following examples are drawn from successful applications of Stages 1, 2, and 3. Since at Toyota Motor Company, the internal setup time of a bolt maker which had previously required 8 hours was cut to 58 seconds. Since at Mitsubishi Heavy Industries, the internal setup time for a 6-arbor boring machine which had previously required 24 hours was reduced to 2 minutes and 40 seconds. Stages 2 and 3 do not need to be performed sequentially, they may be nearly simultaneous. I have separated them here to show that they nonetheless involve two distinct notions: analysis, then implementation. 3.10 Summary. SMED was born over a period of 19 years as a result of examining closely the theoretical and practical aspects of setup improvement. Both analysis and implementation are thus fundamental to the SMED system and must be part of any improvement program. There are two types of setup: internal and external, or ide and ode. The four conceptual stages of setup improvement involve the distinguishing of these two types of setup, and the converting of internal setup to external setup. Once that is done, all aspects of setup can be streamlined. At every stage, however, setup improvements can be realized. Page 32.